So we're working out of the OpenStax Statistics Chapter 6 Excel workbook. So we're on the 4th tab. So this is the example about computer use. As a reminder, you can access the OpenStax textbook for free. Just look in the description of the video. You can also access the Excel workbook for totally free along with slides. Go to divideandconquermath.com. And if you go to the OpenStax Statistics section, you can find everything for a free download. So we're on the 4th tab, so this is about computer usage. So suppose that the average number of hours a household personal computer is used for entertainment is 2 hours a day. Assume the times for entertainment are normally distributed and the standard deviation for the times is half an hour. So getting in the habit of organizing our spreadsheets. I've noted my mean and standard deviation 2 and 0.5. So the first exercise here is really for you. This is kind of a follow-up to the previous exercise. It's a little bit more of a challenge. So we want to find the probability that a household computer is used for entertainment between 1.8 and 2.75 hours per day. So as a probability statement, what would this look like? So this would be the probability that x is between 1.8 and 2.75. So from here, this would be a great time for you to draw the normal curve associated with this and then to do all the calculations with this. And I'll tell you that you're going to have to do 2 different area calculations to ultimately figure this out. You're going to get the most out of this if you actually try the problem. So I strongly recommend you pause the video here, give it a try, hit play when you think you've got it. Okay, so I drew the normal curve. So I've got it actually just hiding over here. So let's see, I will paste my normal curve. I will paste it right here. Okay, so here's my normal curve. So in this case, I want this area between 1.8 and 2.75. For my normal curve, the normal curve is always centered at the mean. So in this case, that's 2. So here's my setup, and I use the fun Galaxy pen to kind of color the space in between. So to figure this out, what we're going to have to do is we're going to have to calculate 2 different areas really. So specifically, we have to start with this one for 2.75. So that's going to give me all of this area to the left. So let's start by finding this area that x is less than 2.75. So I'm going to use my NORM.DIST formula. 2.75 is my x, my mean is 2, my standard deviation is 0.5, and I always type in true. So there's the first part. And then for the next one, so now I want to get this little sliver of area in here. So let me just change the pen color here. Oops. So that's going to be, so let's see, I'll try to make this nice and clear. It's a little hard to draw like this, but I think you can see what I mean. So to the area left of 1.8, that's what I want next. So that's going to be the probability that x is less than 1.8. And so again, I can just use my NORM.DIST formula. So I've got 1.8, I use my mean, my standard deviation, it's going to be true. Okay, so now to find just the area of the fun galaxy color space, so what am I going to do for that? I'm really just going to take the larger area minus the smaller area, and that's going to give me in between. So I will highlight this in yellow. So here's our final answer, so 0.5886. Okay, now what if we wanted to do this using z-scores instead? So that would mean that I'd want to switch this into the standard normal distribution. Well, in this case, then I'd have to find the z-score for both 2.75 and 1.8. So to do that, let's keep this labeled. So for the 2.75 z-score, I'm going to take 2.75 minus the mean. Oops, I forgot to do my equal sign. Equals 2.75 minus the mean. Make sure you use parentheses on top, divided by the standard deviation. So there's one z-score. And then I also need the z-score for 1.8. So I take 1.8 minus the mean divided by the standard deviation. Okay. So now I have a z-score of 1.5 and negative 0.4. These z-scores make sense. So this 2.75, if I wanted to switch this to the standard normal distribution, I would replace the 2.75 with a 1.5. My mu would become 0, and this 1.8 would become a negative 0.4. Okay, so to find the actual area then, so now I can use that NORM.S.DIST function, and I can just subtract the 2. So I need to use the z-score for the higher value first, so that's this 1.5. and then subtract the area associated with the smaller z-score. So as you can see in how I've set this up, so you can pause the video here if you just want to take a look at how I set up my formula. But I took the larger area minus the smaller area and I got the exact same answer. So the two answers match one another. Okay, so that was the first part of this, and the next part of this is here to teach you how to use another important function. So this one's worked out for you, but we want to kind of talk through how this works. So the next question says, find the maximum number of hours per day that the bottom quartile of houses uses a personal computer for entertainment. So this is a totally different type of question. So the bottom quartile, that's referring to the bottom 25%, which means that 0.25, that's already telling us the amount of area that we're talking about, okay? So notice how that is a change from what we were doing before. So in the previous problems on the previous tab and this tab, the idea here is that I have a certain amount of, I have a probability statement that I'm trying to figure out. And probability and area go hand in hand. So when I'm trying to figure out the probability of something, ultimately I'm trying to figure out what amount of area have I, colored in. But this is now going the opposite way. Now I'm giving you the amount of area that I want, and what I want to know is what value would give me this amount of area. So I'm kind of going backwards. So before you had these points down here and then you figured out the area. Now you have the area and you need to figure out the point down here. Okay, so to do this, there are two different ways that you can approach this. And again, you want to get used to doing both because it just kind of depends on the context. So we are kind of doing the inverse operation, and that's how you can remember the formula associated for this. So these are inverse formulas. So there's a little hint here in how these formulas work. So if we just want to find an x value associated with this, which is really what we want in this case, we're going to use the NORM.INV function, and that's going to ask you the amount of area or probability that you're looking for, the mean, the standard deviation, and then again, you always use true. You don't use true. Sorry, that's a typo there. Let me just cut that off, sorry. So if you look at this NORM.INV, so you can see it has probability, mean, and standard deviation. Those are the prompts here. So if we click on the formula that I already filled in, so you'll notice here 0.25, that's the amount of area that's been filled in. And then I do know my mean and standard deviation. That refers back to that original amount of information that we were given before. So if I plug those things in, basically what Excel is going to do is it says, okay, here at the bottom 25%, this x value that belongs down here, this is supposed to be 1.662, so on and so forth. Now, if you didn't want to find the x value, but if you instead wanted to do this from a z-score output or a z-score standpoint, so what you could do is you could do the exact same thing, but now you're going to use the NORM.S.INV function. And that makes sense, right? So the normal distribution, so if we think about it, the normal distribution, the x-axis, this is an x-axis, right? The standard normal distribution, that lower axis is always z-scores. So if I use the NORM.S.INV function, it's a simpler function. All you have to do is plug in what amount of probability or area that you want. So you can see here in the way that I've set this up, I just put in that 0.25, and this has returned a z-score. So this is the z-score for our associated x value. So if we want to, we can then use the z-score formula to back into what the actual x value has to be. So remember, your z-score formula, that's your x minus the mean divided by the standard deviation. That's going to equal a z-score. So using this formula here, you can basically plug in all the information that you've been given, the mean, the standard deviation, and now the z-score, and then you can work backwards to solve for x. So you can see here that that's basically what I do, right? So I take the z-score times the standard deviation plus the mean, and that will get me to the x value. So you can see that these two numbers, they are the same, so it's tomato, tomato in terms of which one you want to get to. So again, it's important to practice both just so that you get really comfortable with kind of flipping between the two distributions. If you invest that time in this chapter, that's going to pay off for you as the class moves along.